Good morning. Hi, Shep Siegel here. It is Sunday, May 28th, and we're going to walk through the Arkville 1705 install to show the process of installing the software, loading a bitstream, and actually moving some packets back and forth between host and FPGA. We've downloaded a tarball, the Arkville 1705 production release. It has a date stamp at the end with the year, the month, and the date. And we will blow out this tarball into a directory of our choosing. In this case, we'll go down into the projects directory and we'll do a tar xvf of .arkville. And out blows the tarball. And now we can see that we have a Arkville directory inside our projects directory. The next step that we'll do is inside the Arkville directory underneath software dpdk scripts is a convenient program called ar install dpdk.shell. We're going to copy a version of this up 4 levels and go there. And now we have a copy of the Arkville install script up in our projects directory. The Arkville install script is a convenience tool that brings down the correct version of dpdk, and we'll run it right now so we can see what that does. ar.install. And it asks us if we want to continue because it will write over a dpdk directory if we had one there already. So we'll say yes, and we need root permission, and off we go to the races. The first thing this shell script does is it checks for the presence of certain packages that are required by dpdk and by Arkville. After that is complete, it downloads from dpdk.org the dpdk distribution, which includes the Arkville poll mode driver. This script will work for CentOS and Ubuntu. If you have a different Linux distribution that's supported by dpdk, you should inspect the script first. With dpdk now downloaded, we see the script calling make so that the dpdk libraries are compiled. Now that the dpdk compilation, including the Arkville poll mode driver, is complete, we can do one other bit of compilation which isn't technically part of dpdk but is useful for the Atomic Rules examples. We'll go into our Arkville distribution and cd into software, cd into dpdk, and we see that, oops, we want to go there. We want to go into software PCI, and we want to type make. These are Python bindings that are used in some Atomic Rules example programs, and so typing make inside the PCI directory builds them. This is not technically part of dpdk. This is something that's used at Atomic Rules for testing, and we'll also do a sudo make install. There, we're done. Okay, the next thing up is to install a bitstream. We have a convenience script that we use to load a bitstream. We'll run that right here, right now, and it'll bring up Vivado in batch mode, pick up the bitstream that is designated for this board, and load it into the hardware. In this case, we're loading an XUPP3R board, and it takes some tens of seconds for the bitstream to load. Now that the bitstream has successfully loaded, we will do a warm reboot of the machine. Now that the machine has rebooted, the easiest way to see if the bitstream has been loaded properly is to do a sudo lspci -v -d1d6c, which is the Atomic Rules code. And we can see here that we have a Arkville FX1 device, 64-byte data mover, and also we'll note that it's in PCI slot 3, which is important. This is probably a good time to check our bash profile. And there are 4 important settings that need to be environment variables that need to be set, RTE SDK, which points to where you've installed or you've had the script installed, DPDK, that is the DPDK release, RTE target, which we recommend simply setting equal to build, which will be a subdirectory within DPDK, Arkville home, which is a path to the Arkville distribution. In this case, it's the Arkville 1705 production release that was tagged on May 26th. And last but not least, Arkville slot, which we're setting to 03, which you recall a moment ago we saw back here when LSPCI told us the board's in slot 3. So at this point, we're almost able to do something with Arkville, but we need to turn on huge pages so DPDK has places to produce and consume buffers from. We have a command line, we have a command where we echo 2048 into the appropriate huge page virtual device. So I'll re-execute that command. And now we have some huge pages. So at this point, we should be able to actually run some DPDK programs to move packets from the host to the FPGA and back. So we'll go to projects, Arkville, software, DPDK. I like starting with test and running runtest.sh. And it scrolled by very quickly as these tests were starting off, so I'll scroll the screen back, but you'll notice here this network device for using a DPDK driver shows up, so that's important. It's probably worth reviewing these other outputs as well, but once these tests kick off, this will begin to run, and this particular set of tests in the DPDK test directory take only a few minutes to run. There's a much broader set of tests in the DPDK app directory, which can take the better part of an hour to run. But at this point, we see tests are passing and packets are moving, so we're well on our way to doing something great with DPDK. I hope this quick walkthrough was helpful to you.